Recording is on.
Okay, so welcome everyone to the August Unique Community Hours. I'm not the usual host today because our release engineers are on vacation or off today. So I'm taking over. So I apologize if it's not in the format you're used to. I'm Cedric Bosdona. I'm senior software engineer in the Uni team, and I'll skip the release engineer part today because I have no update for you today, and we'll jump directly to the topics that we have. So Michael will introduce us to the upcoming changes in the report database. Ahmed will provide an update on his Google Summer of Code project on using AI to help speeding up the pull request tests. And Yerai will show up some root cause analysis with LLMs using the MCP tools that he's working on. And Andre will show about the backup and restore that has been implemented in mgradm. And if they're here and we have time, we could have Siwen or Kathy presenting the state of their Google Summer of Code projects. I don't know what if we'll have time. And as usual, time for question and discussions. Michael, are you ready?
Yes.
Okay, so I'll let you share your screen.
Okay, can you see it?
Yes.
Okay, interesting. I cannot see it on your screen, on my screen. Okay. Welcome everybody. There were in the past some questions about enhancing the report database schema, and I had now some time to implement some of them, I wanted to show you what is new. So the next slide shows you some new columns in the systems table, which is about last boot time, which was requested. So this was missing there. And of course, I have also added that one to the inventory report, so that you can now have also there for the system the last boot time. Then we have a table called systems outdated. And that one is got two new columns. So we have this extra package count. This is about the number of packages which are installed on your system, which are not available inside of a channel which is assigned to the system. So that means when that nobody knows where this package comes from. And another one is a status field, and this is the status you also see in the system's overview page. So it says about that has a critical status or needs reboot and these things like. We have this one now also available in a report, and both columns were also added to the inventory report. Then we got a request about why don't we have hardware information in the report database, and especially there was a question about the CPU, the memory, system BIOS informations, and these kind of things. And there were no report which were listing these things. So I created a complete new table, system hardware, and this table has now all these informations. And I created a new system hardware report, which that now combines this information also together with network information and also if the system is a virtual system or not. So these things are also new. And now another thing, this was requested, I think, here from internal thing. this was something I wanted to do from the beginning on when I started with all these content lifecycle management. That before you have build or promote, that you know about what will change. So what is new when you are building from the vendor channels, so into the first development or test channel. So and to have these differences is something what we will now have in future, and I hope that also our colleagues from Leica will add that one also to the web UI directly, so that you can see it directly there and not only in the report. But there was definitely a request for having this in a report, so I did that one. And we have in principle these things. So everything is identified by the project label, environment label, and channel ID. Channel ID, because we have a channel table in the reporting database which you can join, and then you have also the channel label if you want. Then we have something called diff action. So this is the typical plus and minus sign. So what you know when you call a diff. But we have also the X, which is excluded, which means that this one is a filtered entry. So this appears only for the first environment, because only there we are filtering. But here you can see what packages are filtered out and excluded. For example, if you say that every kernel version above a special version should not be there, then you will see the kernel versions which will never appear into the first environment with the X. Then we are having this for two types currently, for package and errata, and we have an entry ID entry type. Of course, so when the type is package, then the entry ID is a package ID. And if the type is errata, then the entry ID is the errata ID. With this, you can also combine this with the errata table or package table and get more detailed information about the exact package or exact errata, which is filtered or added or removed. And then we have, of course, also entry name and entry description, which is some information that you have directly for the package or for the errata. Okay, so now let me try if I can show you this something in live. So do you see my terminal? Okay, good.
Yes.
So let's start with directly as an example how that looks like with the CLM diff. As you can see here, this is now I have a longer running server where a lot of things were added in the meanwhile. Here for Rocky, a Rocky Linux example. Here we have, as you can see, a diff action packages which are added for Rocky in the test environment. And we have here one errata only, and but a number of packages which will be added when you would do a build. Now let's see. Just a moment. Here it starts to switch to the minus. As you know, Rocky Linux is one of the OS vendors which every time when they are applying a new package update, that they are removing the older version of the package from the repository. And as this was a new feature that we are staying compatible with the upstream, this would mean that you will lose these packages when you now build the environment. They are removed from upstream, so on a build they will be also removed from this repository. So now let's see. Okay, here we are. Now, another environment, which is 15 SP7 environment. Here we have an environment called production. So, and this is now the difference between production and the one where it's cloned from, which is the test environment. So, and you see we have a few changes here, but not so much. So that means if you are pressing the promote button on the production environment and you promote everything what is currently in test to production, you will get these packages added. For test, it looks quite different because this is now test is much older and it applies against the vendor channels. So, and here we have a number of erratas which would be added, and also a number of packages which are new. So on a build this test repository, all these packages and errata would be added. And if we are scrolling deep enough, we are seeing here also our X. I have applied something for the kernel live patching stuff. So that means kernels are excluded. And here we have a number of kernels and grub and Unicode stuff. So with these packages, which are excluded by the filter rules we have applied. So, and this is what you will get from these reporting. Okay, so, and now let's have a look at the other things of the, so I connected here to the report database. Let's have a look at the other things. So, so let's start with the system. So here's the system table, and we got, here it is, last booted time. So that means all the systems are now have now also these last booted. Then we had the system outdated I talked about, where we have these two new columns about package extra count and the status. So extra count, so some are okay, some quite a lot. And we have the status here, some are reboot needed, critical patches are can be applied, that one is up to date. And here we have also a reboot needed. And the complete new system hardware table where we have the machine ID, architecture, and then we have some CPU informations, including all the flags, CPU model version, also the number of CPU socket, CPUs, the number of sockets, the number of cores, the number of threads. These are all virtual machines, so that's the reason why these numbers look like that one. The number of RAM, swap space, and then we are getting into the system and BIOS informations here. So this is in principle what you see also on the system details hardware page in the web UI. Okay. And let me see, spacewalk, report inventory. So here we have now also, where it is, last boot time is available now here, as well as extra package count and the status. Let me see if you can see. It's hard to see it here, so you need to better load it into a LibreOffice table, because then you can read that one better. But it's in there. So now let's see inventory and the system hardware report here with all the CPU informations and the hardware report. As I said, we have here also a primary network interface, hardware address, IP address, IPv6 address, and is virtualized. So these information are also here available. Chassis. Okay, here the thing starts. So the primary address, so here we have the MAC address, we have the IPv4 address, here we have IPv6 addresses, and that one true, it's a virtualized system. So yeah, and I think that was everything. So are there any questions?
I have a question, if I can.
Yeah.
So I think this new table about the CLM environment difference, I think this one can be very useful to take decisions and support the user. But then I assume that you need to have the report database up to date and very in sync, right? I'm not expert on this one, so can you expect it to be up to date, or is this, or how often should it be updated, or how is synchronization?
Yeah. So this calculation of the CLM diff is not that easy. It does not goes instantly. So I created a task-o-matic job which is running every night. So, but I have also some APIs added for that one, where you can trigger that one. And then this table, by the way, we have a very similar table also in our normal internal database, and that's where, for example, a web UI would take these values from. And yeah, of course, you can trigger this regeneration by just triggering the task-o-matic job, or you use the one of the API, and with the API you can also, I think, go directly and just evaluate the data for one special project, or even I think for a special project and a special environment, which is then always a very smaller or a smaller task to be done, and therefore also faster. So these things are possible, and yeah, of course, report database is also regenerated only one time per day, somewhere in the night, and that's definitely something you should know about that one. Yeah, but you can with the API and task-o-matic jobs, so you can reconfigure the task-o-matic jobs when they run, or do an instant run. With this, you get this one really. Yeah, you have the chance to influence when it runs and how it looks like. Okay. And yes, that's something which will also go to SUSE Manager 5.1, so Multi-Linux Manager 5.1, sorry, as I saw a comment here about the question.
Okay, thank you.
Is there any other question? Looks like not. So thank you, Michael.
Thank you.
So now we're going to see the update on using AI to help speeding up PR tests. So Ahmed, the stage is yours.
Can you see my camera?
Yes.
The
screen not yet.
Yeah, still didn't share it. So. Okay, so hi everyone, I'm Ahmed. Currently a Google Summer of Code contributor with Uyuni. And I'm working with Oscar, he's my mentor. And yeah, we're working on testing using AI to help speed up the pull request tests. So I'll just quickly give a recap on what the project was. I introduced it 2 community hours, in the 2 community hours ago. And I'll then show what did we accomplish till now, and what's next, what we'll do next. So let me share my screen. Okay, one sec. Can you see my screen?
Yes, I can see it.
Okay, great. Okay. So quick recap on the project idea. So you can call it AI-driven test selection in pull request tests, or the more technical term is predictive test selection. So what we're trying to do is, let me quickly disable this. Okay. What we're trying to do is, currently we run almost most of the test suite, or sometimes all of it, when any new pull request is created. You run all the test suite. We currently have the recommended tests, which sometimes reduces the test run, but a lot of the times we just run the whole test suite on any pull request. The idea is to use AI to help predict which tests have the highest, are most likely to fail on a new pull request, and you only run these like subset of tests. So instead of running like 70 tests in our test suite, we just run like the 20 most likely ones to fail on the pull request. And so then you reduce the number of tests. The time for the tests is less, so the developer is able to quickly know whether his pull request is all right, it can be merged or not. And of course, GitHub Actions costs and all that. So a quick example that I showed in the previous community hours. On the left is the current test suite. It's reliable and it's already not very slow, but our goal is to make it on the car on the right, which is hopefully still reliable, almost as reliable as the current test suite, but a lot faster. So we run less tests, so it's a lot faster. Okay, so what did we accomplish till now? So I'll get out of the slides and just show you this. You can still see the screen, right? Yeah.
Yes.
Okay, great. So for us to be able to have an AI model or a machine learning model that is able to predict the tests that are most likely to fail, we need to train it on some data. So what we've accomplished till now is that we have created, you can still see this, right? Okay. What we've accomplished till now is that we've gathered the training data, the training data that is needed to train the model that will predict the tests that are most likely to fail. We have gathered it all. So let me explain what's going on here. Okay, so how this goes is that we gather training data for the pull request related to a pull request. Again, the goal is to predict the tests that are most likely to fail on a pull request. So we get some data related to the pull request, and we get some data related to the tests. And then you give the model the data related to the pull request and the data related to a test, like any specific test, and it guesses, the goal is for it to guess the probability of this test to fail. So pull request number 1 with test A, then it guesses okay, this will probably have an 80% chance of failing. This is the goal. So here we've created all of this work generally is built on a paper that Facebook published a couple of years ago, where they implemented this whole thing at Facebook, and it actually worked pretty well. So we're trying to using this as a base and then building on it. Okay, so explaining the data we're able to gather here. So this port, the first 4 columns are the data related to the pull request. We get the extensions of the files modified in this pull request. Then we get how many times all the files in this pull request have been modified in the past X days. So here, the files that were edited in this pull request number, this number, the files in there haven't been edited or touched in the past 3 days at all. This is the same pull request. It's repeated. I'll get to why it's repeated. Anyways. And then the files have been edited 57 times the past 56 days and 14 days. The idea is this shows which types of files were edited in the pull request, and the modification shows whether this area is an active development area or not. If it's being modified a lot lately, then it's an active development area. It might have higher risk of failing against tests, but if it's not modified that much, then the risk is less. Currently, this is only the data we gather for pull requests. This actually was only the data that the Facebook paper was gathering. They had something else build dependencies where they link how close a test is to specific files. We don't have that till now. So we're still not sure if this this will produce accurate results, but yeah, we'll trying given the time currently. So anyways, so this is the pull request data. Then this is just for readability. I add here the pull request number and the run number, the GitHub Actions run number. Anyways, we can skip these. Then we have data for the tests. Coming back to why the pull request is repeated a lot, since for each pull request, I gather the test results that it had with all the tests. That's why it's repeated. So this pull request with this test passed, and this pull request with this test passed, and so on. And then we gather data for each test. So for each test, this test, its category, I'm using here the Uyuni categories, how much scenarios it has. Okay, sorry, feature means test in Cucumber. just to like clarify that. So these are the tests. These are the categories, as you can see, and scenario counts are like the sub-tests inside the test. A scenario in Cucumber is like, the sub-tests. So if a test has a lot of sub-tests, it might have a higher probability of failing. And then I think this is one of the most important features, these failures. These are the historical failure rates for the tests. So it shows how many times this test failed in the past X days. So in the past 7 days, how many times it fails, and so on. So maybe you can see here, like this test failed 7 times in the past 56 days, or this test failed 3 times and then 1 time in the past 28 days, stuff like that. And then lastly, we also store the results. Okay, so currently we are able to collect all this data for all the past PRs in like the past 2 months. We're able to get this whole data and collect it so that we can train a model. Of course, here on this pull request, all the tests passed, but on others, like they sometimes fail, specific tests fail. So yeah, this is like a huge training data. You can, as you can see, like multiple pull requests with multiple tests. Okay, yeah. So we're gonna use this to train a model to be able then to predict. So yeah, that's what we've mainly accomplished, like getting this data. It had a lot of tricks to it, how to like gather this stuff and keep it up to date. Yeah, Jordi, please, yeah, you can go ahead.
Yeah, I hope you can hear me well.
Yeah, I can hear you. Yes.
Okay. So I have a question. The failures are related to the pull request, or are the failures in general of this feature?
Yeah, that's a great question. No, failures in general, like in all pull requests in the past 56 days. So
Okay.
no, they aren't related to the pull request.
Okay. Thank you.
Yes, thank you for asking. Okay, so actually, yeah, it's a good time to take questions. Does anyone like is something not clear about the data? If anyone like has any ideas they want, yeah, like please, any question that came to your head, please just go ahead and say it. I would love to hear. Okay, let me go ahead then, and if anyone has any questions at the end of the presentation, please. Okay. So a quick explanation of, okay, Cedric, if I took too much time, please let me know so I can speed things up.
Well, we seem to be still on track.
Okay, sounds good. Okay, so a quick explanation of how we were able to gather this data. So I created a database, a Postgres database, like a relational one. I can show you here the schema for it. It just stores the each and every test run that happens in Uyuni. Like when a pull request is created, a test run happens on it. Maybe if you create new commits and you push, a new test run happens. This happens with all pull requests. We gather all the test runs, some data like metadata of the test run, on which PR number it ran, the run number. Like this means it's 1 if it's the first run on this pull request. It's 2 if it's the second run on the same pull request, and so on. Like some data for it, if it passed or not, when it was executed. And then we link it with the modified files. This is how I'm able to get the like file extensions and maybe later on more data related to the files that were modified in this pull request. And we also link it with the features like the test results. And we also store each test, its scenario count, its category ID, so we can like be able to generate this data. I can show you quickly how it looks in real life. So this is the same database, but actually implemented. We have the test runs. So this is this run on this pull request. It passed, and when it was executed, and then I link it with features here. Also, this database stores up-to-date like scenario counts of tests in Uyuni, which categories and all that. And yeah, and then I have this, and then I'm able to get this generate this training data from it. Like using a script, I can generate this training data. And I think this is a very like, it can also be used for visualizations later on. Like you can check how many scenario counts in the tests we have. You can visualize the historical failure rates of tests, stuff like that. And this is a very small diagram. Let me on like how we fill the database currently. So this is the database I just showed you. We created a script that is able to like gather all the test runs that happened in the past 2 months and store them in the database. like as I just showed you. And then currently it will be merged like in a couple of days. We will merge a GitHub job that automatically, with every new test run, it will insert it into this database so that we can always keep adding data to it, so we can have more training data and we can keep the data up to date and all that. And then I have a script that I use it to generate the training data CSV that I just showed you here. This one. Okay, so that's what we've done till now. So I think this is great. Like, we currently have the training data, at least, the basic training data. So we can continue and test and see if it will produce accurate results. So what's next? The next steps are, the next steps are that we just use this training data, pre-process it to get it ready for using it as training data for a machine learning model, or specifically a machine learning classifier. Train a machine learning classifier on this data so that when I give it any new pull request, it can just go on all the tests in our test suite, predict for each test the probability of it failing on this pull request. And then there's some other stuff that needs to be done, like we need to decide a threshold. So let's say this model predicted, let me show you something. I should have added it in the slides, but anyways, let me show it to you real quick. Okay, yeah, here you can see this one, right? Okay, so the model will predict something like this, like the model that we'll do still will output something like this. So if I give it a pull request, it will go on all the tests and then say test A has a 92% chance of failure, and then this has this chance, and then we need to decide the threshold. Okay, so I got this from the model. Which tests will I run on the pull request? So I need to decide the threshold. Let's say any test that has the model predicted, any test that the model predicted will have a higher than 70% chance of failure, then I will run it. Deciding this threshold isn't easy. We need to find it. Like, it's like a trade-off between how many tests you run. If you decrease the threshold, you'll run more tests, but it'll be more reliable since you run more tests. But if you increase the threshold, you'll run less tests, so it'll be faster, but maybe less reliable. So yeah, we'll play with it, and then we then just deploy it. So yeah, the next steps are just for like training this model that I said, and then hopefully if it's producing good results, we deploy it. We might also play with gathering more test data for like the pull request. As I said, build dependencies and all that, but we'll see. So yeah, sorry if I feel like I took a bit more time than I expected, but anyways, thank you very much for listening. If you were able to stay with me this whole time, and please ask me anything, like any question that came to your mind, whether you feel it's like just ask me anything if you have anything in mind. Thank you.
So do we have any question? I have a short one. So how do you plan to handle tests or scenarios or features that are being removed? So if in some pull request we remove some scenarios, we may still have history that this one was failing, and then are we likely to ask to trigger it again?
Oh, I see. Okay. So yeah, you mean if a whole test is deleted, like?
Yes.
So if a whole test was deleted?
Well, you may not have the answer now.
Yeah, but this is a good question. Yeah, I haven't thought about it actually.
It's just food for thought.
Yeah. No. Thank you for sharing this. Yes.
Maybe sorry. Maybe the model you built will capture that behavior. Will if it generalizes enough, maybe it will just detect that. I'm not sure. But yeah, it's an idea.
Maybe I could actually the plan was. Let me show you real quick. The plan was to use these features, like the model would when it gets a new pull request, it just loops on all these features in the database, and then it predicts the probability for each one of them. But actually, if let's say this test was deleted, it will still be in the database. Except it's pretty tricky if it will be hard to when it's deleted in the GitHub to delete it here. I think that'll be tricky. Maybe I can let it predict on all of them, and then if it predicted this one will fail, but I don't find it in the test suite, then I don't run it. but yeah, it's an interesting thought. I'll keep it in mind while building this.
Okay, maybe we can switch to Yerai now.
Yeah.
Thank you,
The-
Ahmed.
Yes, thank you.
Yeah, I hope you see my screen.
We're not yet in presenter mode, but just
Why not? You don't see it
we see the
now?
regular the LibreOffice window, the
All
Impress
right.
window, not the.
In presenter mode. All right.
Now you
Thank
have
you.
the presentation.
All right. Well, we have been working in using LLMs in Uni to achieve or to research if we can get something useful to do with them. And there is this new called MCP that has become a kind of a hot topic in the AI world. Maybe you have heard about it. So we had an idea of trying to do a root cause analysis using LLMs and see how it worked. Well, if you have not heard about MCPs, is this Model Context Protocol. It's a protocol was designed by Anthropic that standardizes how LLMs access to applications, how applications provide context to these LLMs. Well, as this sentence is, think of it as a universal connection mechanism that simplifies how LLMs obtain that context. So what we do is build an MCP server that exposes tools. So these tools can be then invoked by large language models, and this way LLMs this tool can enable LLMs to interact with external systems such as well, database, APIs, whatever you call it. So the question that we want to ask to answer is, can we manage Uyuni using natural language? I mean, can we leverage LLM capabilities to help the Uyuni system administrator? The Uyuni NCP server that you can access, we have been working in that repo there, uses the Uyuni API to so we expose some tools that query the Uyuni API, and you can query these tools using an MCP client. So that's what we wrote there. We developed tools that our MCP server will make available for the LLM to utilize, and once you have the response from the tools you call, you add that response into the LLM context, so the LLM has all these new information to process a response. Well, that's the work we did with the Uyuni NCP server, but we had another question can we use LLMs to help with root cause analysis when an issue pops up? Can we use it for troubleshooting an issue? Given that logs are very big files, and there are a lot, and LLMs have context limits, and given that we have context limits, you cannot feed the LLM with all the log files, and the number of tokens the LLM can manage is limited. So we needed a way to reduce this context. That connects us with some work we did past year, or at the beginning of the year also. The health check tool, that is a tool to speed up the debugging process, and has all those components. But we want to focus in one of them. Well, this health check tool was presented in the Uyuni community hours, I believe. So the presentation might be available if you haven't, if you didn't attend. But we want to focus in this low-key component. It's a low-key, it's a log aggregation system that only indexes metadata rather than full texts of log lines. So we basically extract from logs what we think that is interesting. So we achieve this context size reduction, and we make it possible for the LLM to use it, to use log information, and to perform the root cause analysis. So the health check tool, as it is now, works from a support config. So you would need to create the support config when you, you stumble upon an issue, you generate the support config and use the health check tool to spawn this container with the Loki server. And this Loki server would ingest this support config information and filter it and make it available for querying. So what we want to do is feeding the LLM with this information that is stored in the Loki MCP, in the Loki database. So we built this Loki MCP server to expose tools so the LLM could query the Loki server. So that's the idea. That's the idea using the work we did in the health check, building a Loki MCP server. So the Loki MCP server can be utilized or used by the LLM. And a detail about the internals of how Loki works is it has in an LoQL language that has a certain syntax that can be complex. You can build complex queries, and of course, if the LLM has to write or those queries, usually fails. It usually has the wrong syntax. So we found out about this problem of the LLM doing bad queries when using the official Grafana Loki MCP server. That was a very simple Go-based Loki MCP server that just forwarded the query that the LLM created. So it wasn't useful for us. So we tried it, but we did not get good results because of these LogQL syntax issues. So we developed our own Loki MCP server with tools crafted to meet our needs. And this is a screenshot from the Gemini CLI MCP client, and I have two MCP servers configured. One of them being the Uyuni MCP server that exposes all these tools. You see there listed, so you can perform that actions, or the LLM can perform those actions in your behalf. So you would write, for example, for the Uyuni MCP server to get the CPU of a certain system, and the LLM would tell the MCP to query the Uyuni server, and the LLM would then get the response back. So you would have that information. And but what we developed regarding MCP is this second MCP server set of tools we see there, the Python tools, to query the logs for the different components, for example, Apache, Cobbler, Salt, etc. All right, so with that available, you could try it with an MCP client. You can wrote a prompt, and you would get a root cause analysis of what the LLM thinks that might have happened. Having that information, you see in this screenshot, you see that the reference part is telling you what tools the LLM used. So I'm changing. I have video here. I don't do it like live because the LLM takes like 30 to 45 seconds to think, and it's weird to just wait in silent. So so you see I prompted, I used Gemini 2.5 Flash, and I got a response. So if I go here, I can see how the LLM actually queried the Loki server and got some of the most interesting log lines to do this root cause analysis and to pinpoint the issue that you might what caused the issue that you are experiencing. What I did with in this example was have a local instance shut down the PostgreSQL service, and the LLM just pointed that out. So at least he knows what happened, or it knows what happened. So yeah, that's it. So if there is any question.
Ahmed?
Yeah. I was a bit confused. What was the issue with the Grafana official MCP server?
Yes. So with Loki, you have to write an Loki SQL query, like an SQL query, but for Loki, no? So the official Grafana Loki server just takes as a parameter, just takes the query. Is the model, in this case Gemini, is unable to write a proper LoQL query, so it Gemini thinks we need to query this and this and that, and the query is not well formed, so this will go as a string parameter to this Loki MCP server. But of course, as the query is bad formed, it will fail. So you will see as a result of the tools, you will see errors, syntax errors as the result. So we developed our own crafted Loki MCP server with the knowledge we have about how we have to query for the Apache component, how we have to query for the Salt component. So we expose specific tools, and the LLM knows that those specific tools are available. So it uses it and extracts no syntax problems, no syntax issues in the way.
Yeah, that makes sense. Thank you.
All right.
Thank you, Yerai. We'll quickly jump to Andre as time flies super fast.
Yep, okay. Let me share the screen. I should be really quick. It's not
So Andre will tell us about backup and restore.
Yes, so let's see. You can see my screen, right?
Yes.
Already. Okay, perfect. So instead of slides, I opted to show you a documentation. So this is a new thing which we added in our latest release about backup and restore. Now, if you remember before doing the containerization, and even after containerization, the backup restore procedure was basically a bunch of instructions how to copy individual volumes or directories and whatnot. So instead of this list or manual workthrough, we added commands to mgradm, to the unit tools. By default, really it creates a snapshot of actual state, of actual what you have in volumes, your database and everything. important point here is that it is not yet another backup solution like rsync, Borg, or whatever else. This thing really takes what is deployed, the system, and complete it into one location on one directory. And then, based on this directory, you move it somewhere else by some normal backup methods like rsync or Borg or Bakula or whatever. Because we do not do compression here, we do not do different some deltas. We just really take what you have and make a copy of it in some format that it's not dangling anything, and you just compact one. It has a basic validation so when there is some bit corruption, it's detected by checksumming, but that's it. No computation of deltas, no uploading it to S3 bucket or whatever. It is the part of actually getting it out of the running system outside is still a manual work, and there are multiple of other tools which are better to do. So what we have in options is taking a normal backup. It backups everything: volumes, the database, images, Podman network, system configurations, and put it on one place, and then you can move it. Or because this also requires some downtime because of the database backup, it is possible to do partial backups, like you can skip database. That means it will download every volume, everything here, except a database, and that means that it will not be shut down, right? It will still be online, so you don't have any downtime. Then, after the backup volume is finished, you can do another backup call, by just skipping all volumes, and that means it will backup on the database. This will trigger a downtime for a little while, but only for a time being for this database, and then restart it. Of course, it comes with a little higher risk of inconsistency, just because there is a time delay. So if you are running it during the night, and also during the night you have a repo sync running in the background, there might be some issues, but these usually can be self-healed. If there are something missing, that repo sync can should be able to recreate. There is also possible with the skip volume, you can skip individual volumes which you don't want to know that you don't want to preserve, like if you have OS images or something like that. Drawback is that there will be still a database entry, but if you know that you don't want these images, you can then delete it manually, and it will just delete it from the database and so on. And if you are able to skip volumes, there is an option to be able to add extra volumes, something which is not part of the Uyuni system, but you like have modifications for appending extra volume to the containers. So you want to be included in the backup. You need to specify it here. We are not doing any parsing of system defaults, whether there is any extra amounts or not. So it needs to be taken care by specifying it in a backup thing. And yes, and of course you need to do this is I'll just show you how it works. So I have let me show you. This is empty Uyuni system. I just deployed yesterday, just so the backup is really quick. So it's really empty. This is my DHCP 190. This is the server. So the backup is really easy. I just create one more thing. This is a tumbleweed system. So not even though it is running here, this is not yet completely supported yet, but officially you can still run it there. If I create a backup, to create a really basic backup, you just create like this, and it will create. You specify the target directory, and it will. You could see that it stopped the services because I am taking backup of the data of the database as well. Then it backups all the volumes. After the volume, it is backing up the container images for server, for database, systemd services, Podman configuration. Podman configuration means Podman network and also Podman secrets. Speaking about secrets, by default, we use a file driver for Podman secrets, which means that these secrets are actually not encrypted. They are only encoded, base64 encoded, so nothing fancy. That means if you have a deployment where the Podman secrets are using like GPG things or another drivers, this will not work here. The backup will report this as a warning and will at the end will write you that it backupped files but with some warnings. So it will notify you that some like Podman secrets were not able to be backed up, and you need to do that manually. And if we take a look in how this looks like in backup, so it is organized in some directories. Every volumes are separated, images are separated. Every volume, every star we create have a checksum for it, except images, because images they took it with them. The Podman is completing it by ourselves. We don't have to do the recomputing of the images here. Yeah. Okay. Quickly, what other options we have? We have also a dry run. So if you want to see what would happen and everything, should be able to, like, if we can decode the secrets, if we can parse the network, Podman network, you can try with dry run. It will not write anything. Another option is no restart, because now, after backup is finished, it automatically restarted the service. If you are doing this backup for migrating to another system, pass no restart, so it's not started again. And then you have options to skip some various options. So now about restore. Usually in a restore, you want to restore it when something happens, like this system is no longer running, which coincidentally is what happened right here. Even though if you see, it reports everything is healthy on a Podman PS. If I try to access it, it will not access it, because we found out just yesterday and today that there is a bug in NetAwark for a Podman, that the latest NetAwark does not work with the latest NF tables. So if you have NF tables like on a latest Tumbleweed 1.114, it does not work. You need to flush the tables manually after each container restart. It's not ready only just for Uni, it's for everyone. So what do? We start a new instance. So let's see, new Uni. This will download completely new OpenSUSE Tumbleweed minimal image. Start a VM. Let's start VM. Okay, so VM is starting here. It will be very quickly ready. I do not have any combustion thing, so we just can go through the first boot. Okay, we don't need encryption. So this is really just accept everything, really simple password. And now we need only to get here. So what was the IP address? 10.152. 5132. Okay. Yes. Skip. Okay, now we have these additional things. So we should be able to log into it. Yes. So let's just copy everything we have. So var backup to this machine. Okay. We can write to it. So in var backup, we should have. Oh, okay. So I got added just here, right? Yeah, it is here. No worries. Also, this is a brand new thing, so I forgot I need to copy also mgm. Okay. And I can try to do restore of this thing. And it will fail, of course, because we do not have Podman installed. So I'll do that quickly. It is doing the sanity checks. Part of the sanity checks is also check whether the size is, whether you have enough disk space to restore it, and if there is not enough space, it will bail the similar way like this. And not sure if it is doing also on a backup. I don't remember now if this sanity check for spaces on the backup side, but at least it's on the restart. Okay, we just do the restore. You wait a little small. So now it restored all the volumes and also loaded the images. And once it is done, it will just stop. It will not automatically start the services until we are told to do so. I think there is an option to auto start it. Yes, there is an option -- restart. We can just start it, and now we need only to wait until this. So now we can see that the backup, the restore, which is also the main part why this was implemented, because previously not only the backup was complicated, restore was also more complicated. We need to pull it down from the restore location, put it to the volumes. With the SMDBA backups before, sure, benefit was that there is no downtime. The SMDBA backup could work online, but the restore was always much more difficult to get all the files to recompute the database, because it was storing these val files, the write-ahead logs and so on. So it was little complicated. Here, part of this backup is everything, included images. So there was no need to download anything from registry. Everything. It will just work as soon as it's healthy. So this was the HCP32. So let's check the HCP32. Okay, self-signed certificate, and we have it. We have running system basically. When one broke, another one was spin up like in 5 minutes. And I think yes. One last thing I wanted to say. Yeah, speaking about the SMDBA. Of course, the SMDBA was just true candy about some Postgres configuration. So if anyone really needs database backup, online backup without anything, it is still possible, because it's functionality of Postgres itself. So SMDBA basically was only enabling archive mode and was using a custom archive command, which was testing that the copy was successful and everything. But this is still possible to do even with latest UNI. Only the SMDBA no longer works because it was not adapted for 2 different containers, but manual work is still then possible. Okay, and that's it. If there are there any questions?
Well, I have a remark
Yes.
here. Is
Uh-huh.
that the restart is not renaming the machine.
Yes.
So
Yes,
here
yes,
you
yes.
moved it to DHCP32, which is a different name, so you would have to rename it as well.
Yes, good point. Of course, ideal scenario, you just switch your DNS because you don't want to mess with clients. So when one server fails, you just spin up next one and change the DNS, and then it should work.
Okay, any other question? And I believe it's time for general question and answers on Uyuni. So if anyone has something outside of these topics, can bring them now. Well, if there's nothing, then we can close the meeting. Thank you all for your time. I hope you learned things to hear. And it is always a pleasure to see the progress of all these projects. Especially kudos to our Google Summer of Code students. They're nearing the end for some of them. Yeah. So we'll have Kathy and Siwan next time. Thank you all.
Bye.
Bye-bye.